Hey guys, good morning. Happy Monday. We have just about 3 weeks left of school and we're almost done with chapter 9. So let's do today's lesson 9.2.2, more solving inequalities. This intro here says in lesson 9.2.1, you learned how to solve inequalities with one variable. Today you will focus on special inequalities and learn how you can use inequalities to solve an application problem. 9-56 is our first problem, and it says review what you learned in lesson 9.2.1 to solve the inequalities below. Represent your solutions both as an inequality and on a number line. So we had some practice with this on Friday. I want you to remember that when we solve an inequality and we represent it on a number line, we want to first find the boundary point. And the way that we find the boundary point is we treat this like an equation. So momentarily, I'm just going to put an equal sign instead of the less than symbol, and I'm going to solve. When I solve, I get positive 5. That is my boundary point. So when I draw my number line, this is where I'm going to draw my circle. Okay, 1, 2, 3, 4, 5, 6. Now, whether it's an open circle or a closed circle depends on the inequality symbol. If it's the less than or greater than, it's an open circle. And if it's less than or equal to or greater than or equal to, it's a closed circle. So in this case, it's an open circle. And now I have to test points on either side of my boundary point. So a point on this side and a point on this side, and then whichever point makes the inequality true is the direction in which we shade. For example, I'm going to plug in 0, because 0 is a pretty easy number to plug in. And if 0 makes my inequality true, I'm going to shade towards 0. Here's my original inequality, what we started with. I'm going to plug in 0. 0 minus 7 is just negative 7. Is negative 7 less than negative 2? The answer is yes. This works. And so we're going to shade towards 0 in the left direction. Okay, let's be thorough. Let's test a point on the other side just to prove that testing a point on the right side doesn't work. So again, here's my original inequality. Let's plug in 6. 6 minus 7 is negative 1. Negative 1 is not less than negative 2. So that inequality is false. Therefore, we do not shade towards the right. Okay, so there is our number line. Now the last thing that we have to do is just write the solution as an inequality. So you start with x. And then the nice little trick is that your inequality symbol can come from the number line. For example, we're shading towards the left. It's like an arrow pointing towards the left. And so this part of the arrow is that inequality symbol. And again, since it's an open circle, it's just less than. It's not less than or equal to. What number do we use? We use our boundary point, which was 5. And that is it. Okay, so both the number line and this inequality, that is what we want when we solve these inequalities. Okay, let's do part B. So again, treat this as an equation and then solve for your boundary point. 2 equals 5m minus 8. Add 8 to both sides. So m is equal to 2. That is where our boundary point is. So let's draw our number line. And I usually include negative numbers on my number line, but as long as you have enough numbers on your number line to show your boundary point and to show which direction you're shading, I think you are fine. Okay, circle here. Because it is less than or equal to, the symbol is, this would be a shaded in circle. And now let's test a point on either side to see which direction we are going to shade in. I'm going to take my original inequality. Let me write this in black ink. And let's plug in 0. So 3 times 0 plus 2. Okay. 3 times 0 is just 0. So 0 plus 2 is 2. 8 times 0 is 0. And then 0 minus 8 is negative 8. Is 2 less than or equal to negative 8? The answer is no. So since 0 does not work, we cannot shade towards 0. What does that mean? That we're going to shade in the opposite direction. So one more time. If 0 did work, I would shade towards that direction, but when I plugged in 0, it made my inequality false. Therefore, I'm shading in the opposite direction. And if you'd like to be thorough and check that this direction works, pick 3 or pick 4 or any number bigger than that. Plug it into your original inequality and make sure that it works. Okay, here's our solution as an inequality. X, we have this arrow like this. Because we have a closed circle for our boundary point, that's greater than or equal to, and then my boundary point was at 2. And this is my solution. Okay, here is a shortcut, because I know that we love shortcuts. For part C, what I'm going to do is I'm going to use my normal steps to solve for the boundary point, but I'm going to keep the inequality symbol. And the inequality that I get as a result will be my final solution. For example, let's just keep this to show you what I mean. Keep the inequality symbol, that is, and solve for p. Okay, add 2 to both sides. I now have 2/3 p is greater than negative 2. To solve for p, let's multiply by the reciprocal. So multiply by 3/2. Multiply by 3/2. This cancels out. So you're left with p is greater than, and then negative 2 times 3/2 is negative 3. And that is actually your solution. Also, I'm just realizing that I wrote x instead of m in part B. Let me just fix that really quick. Not that it matters too much, but just to be consistent. So this is actually our solution, which is nice. That just means that I have to do my number line, and I have my solution as an inequality and represented on a number line. So draw your number line. Oops, I can't count. Okay, this inequality is strictly greater than, so when I draw a circle on my boundary point on this -3, it's going to be an open circle. And this inequality symbol, greater than, looks like an arrow pointing that way. And so I'm going to be shading to the right. And we're done. Okay, so that saves us a little bit of time. But we're going to see in these next couple of examples that there's just one small thing to remember when solving it this way. Okay, so part D. Again, keep your inequality symbol, but solve for your variable. So let's distribute here and here. In this case, distribute -3. So we have -3 times x is -3x. -3 times -1 is +3. Combine like terms. Okay, we are close to being done. Okay, this part is really important. When you divide or multiply by a negative, please write this down. When you divide or multiply, it's not an x, by a negative number, flip the symbol. Okay, I can go into more depth about why this works, and if you're interested in hearing that, please send me an email. But for the sake of keeping this video not terribly long, just take my word for it. So here, okay, when I divide both sides by -4, I'm left with an x on the left side and a +3 on the right side. And this greater than or equal to is going to flip to a less than or equal to. Okay, so that's what's happening. It's flipping. So here is my solution as an inequality, and all I have to do now is just draw the number line. So draw a closed circle on your boundary point. Okay, I have a 3 here, so draw a closed circle there. And again, the inequality symbol in our solution looks like an arrow that's pointing in the direction that we shade. And so if it looks like it's pointing to the left, then I'm going to shade towards the left. Again, and that only works if x comes first in your inequality. Okie dokie. Let's keep going. Combine like terms here for part E. You might already notice that I have the same expression on both sides. If I add 3 to both sides, and then I subtract 9k from both sides, I'm left with 0 is less than or equal to 0. Is this true? This is true. This is always true, and If this were an equal sign instead of an inequality symbol, we would usually write all real solutions, all real numbers, and that's what we're going to do here as well. Because that is true. 0 is always less than or equal to 0 because of that little equal part. Now for our number line, what this means is that there is no boundary point. We're just going to shade the entire number line. Okay, if every single number is a solution, then every single number gets shaded. All right, now let's do part F. Here for part F, we get 0 is less than 0. Because we don't have the or equal to part, we're missing this part. 0 cannot be less than 0. If two numbers are equal, one cannot be less than itself. And so this is false. Typically, when you have an equation and you have two numbers that are not equal, or you have an equation that's false, you write no solution, and that's what we're going to write here. How do you represent that on a number line? Well, you just don't shade anything. So here, everything is shaded. And here for no solution, nothing is shaded. Where does that difference come in? It's in that symbol, okay? With less than or equal to, that equal to part is important. It's missing for part F. 0 cannot be less than 0, so that is no solution. I hope seeing this again was helpful. Please email me if you have questions or if you still need some help with inequalities, but I'm going to move on to 9-57. The United Nations. At the end of this chapter, your team will have the exciting responsibility of representing a country at a special meeting of the United Nations, the UN. The UN needs your help preparing for future large-scale disasters. You will need to help find a solution that not only works best for the country you represent, but also accommodates the needs of each of the other countries. To prepare you for this task, the next several lessons will present daily problems to familiarize you with important issues and concerns of other countries. Start by writing and solving an equation or system of equations that represents the problem below. Be sure to define any variables you use. Okay, so a little bit of practice of chapter 4 stuff. Let's see. Turkey has a population of 66 million people and is made up almost entirely of two ethnic groups, Turks and Kurds. There are 4 times more Turks than Kurds. Write an equation and solve it to find out how many Kurds live in Turkey. So I want to take you back in time to chapter 4 when we were writing systems of equations. The very first thing that we started with were let statements. So since we have Turks and Kurds, let's just let T represent the number of Turks and K represent the number of Kurds. So let T equal the number of Turks, capital T, and let K equal the number of Kurds. Okay, Turkey's population of 66 million people is made up of these two ethnic groups. So our very first equation would be T plus K is equal to 66 million. Okay, and then this part of this sentence says there are 4 times more Turks than Kurds. So the number of Turks is equal to 4 times the number of Kurds. You might be tempted to say, hey, Ms. Ramirez, wouldn't it be 4t equals k? Well, there's more Turks than Kurds, so this would be the way to write it. And finally, when we solve an inequality, we can use equal values or substitution or elimination. This would be a good substitution problem because we have t equals here. We have that t equals 4k, so we can substitute that in here. So my new equation becomes 4k plus k equals 66 million, which means that 5k equals 66 million. If I solve for k, if I divide both sides of this equation by 5, I would get 13,200,000 for k. And if I plug that back in here and I solve for t, I get t equals 52,000. Why do I keep saying thousand? 52,800,000. Okay, so there are 13,200,000 Kurds and 52,800,000 Turks in Turkey. All right. Last problem, 9-58. In 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Similarly, the nation of Cameroon plans to give flowering sata trees to other countries this year. When asked to decide which sata trees make good gifts, Cameroon's chief arborist explained, "We plant sata trees that when they are 6 centimeters tall, and they grow 9 centimeters every year. The trees only flower when they are taller than 150 centimeters. It is very important that the trees Cameroon gives flower this year. It would be considered an insult to receive a tree that did not bloom. Luckily, Cameroon has many groves of sata trees from which to select its gifts. How old must the trees be so that they will flower within the year? Discuss whether an inequality or an equation is appropriate for the situation. Be prepared to share your reasoning." Well, they said that the trees only flower when they are taller than, so greater than 150 centimeters. So since the trees bloom when they are taller than 150 centimeters, and inequality would be appropriate. Okay, part B says, part B, write and solve a mathematical sentence to determine how old the trees can be so that they can flower this year. Let's see. Well, the sata trees, they are planted at 6 centimeters tall and they grow 9 centimeters every year. So I want you to kind of think of a linear inequality. Think back to a linear equation, actually. When you were dealing with y equals mx plus b, We had slope, aka growth, and we had starting value. So if you plant a tree at 6 centimeters tall, that would be your starting value. And then your growth would be the growth every year, so that would be 9 centimeters. So I have part of my equality here now, 9x plus 6, and I need to know when it's going to bloom, when the tree is going to flower. So that means that it needs to be taller than 150 centimeters. So it needs to be greater than 150. So once again, this 9 was the growth. This 6 was the starting value. Okay, how tall the tree was when it was planted. And this is the minimum height for the tree to bloom. So now we need to solve for x. So let's do what we've been doing. Keep your inequality, but solve for x. So subtract 6. 9x is greater than 144. Divide both sides by 9. X is greater than 16. Okay, if x is greater than 16 and they asked us to determine how old the trees can be so that they can flower, that means that the trees must be more than 16 years old. More than because we have the greater than symbol. Okay, last part. Later, the arborist added, I almost forgot to tell you, when the trees become very old, they stop flowering. Make sure you choose trees that are no more than 240 centimeters tall. Discuss how you can use this additional information to make sure you choose trees that will flower. So, let's take that same first part, 9x plus 16, plus 6, sorry. We want it to be no more than 240 centimeters tall. So we want it to be less than, but it's okay if it's also equal to 240 centimeters. So this is less than or equal to. Okay, again, this expression represents the height, yes, yeah, of my tree. And in this case, I want to make sure that it's less than or equal to 240. So let's see what we get when we solve for x. Our goal is to figure out what's the maximum age for these trees. Okay, at what age do they stop flowering so that we can pick a tree that's younger than that. Okay, solve for x. Okay, and this should be 26. Yes. All right. So this means that not only should the trees be more than 16 years old, but they must be younger than or equal to 26 years old. All right, so that is it. If I want to sum up this last part with one inequality, then x, the age of the tree, should be greater than 16 years of age, but less than or equal to 26 years of age. Oh no, what happened? Okay, here we go. So that's it. We practiced this problem to kind of see how inequalities come into play with word problems. And so if you have any questions, please send me an email. But that is it for today. Have a great Monday.